Dear students, today we are going to discuss about the topic latent heat of chapter 1 chemistry class 9th. Now first of all, we should know what is the meaning of the word latent. Latent means hidden. Latent means hidden. Now in this class we are going to discuss about this latent heat. Now have a look on the setup. Here we have a beaker which is almost half filled with ice. In this beaker I have inserted a thermometer. This T means thermometer. The bulb of the thermometer is here. We should take care that the bulb should not touch the walls of the container, neither the bottom of the container. So this is the bulb of the thermometer which is completely immersed into the ice cubes, or we can take crushed ice also. This thermometer has been held by the stand. Now record the temperature. We check the temperature as to be 0 degrees Celsius. The temperature of the ice cubes is 0 degrees Celsius. Now keep this apparatus for few minutes. For example, we kept this apparatus for about 5 more minutes. Then after 5 minutes, again record the temperature. So after 5 minutes, we see that some of the ice gets melted, some of the ice get melted, and now we have some ice cubes as well as some icy cold water in the test tube. So when we record the temperature after 5 minutes, it is still 0 degrees Celsius. Now what is the reason behind this? Since 5 minutes the apparatus is taking the heat from the surroundings, then why after 5 minutes the temperature is still 0 degrees Celsius? This is the concept of latent heat. The heat which is being absorbed by the container since 5 minutes is not utilized in increasing the temperature, but the heat has been utilized in increasing the intermolecular spaces, or we can simply say the heat absorbed during these 5 minutes has been utilized to overcome the force of attraction between the particles of the ice, so that the particles will move somewhat apart from each other and the solid ice get converted into the water. So that hidden heat which has not been recorded by the thermometer is called the latent heat. Now latent heat is of two types. Latent heat of fusion and latent heat of vaporization. So we will discuss it further. First come to this figure again. Now allow this container for 10 more minutes. So after 10 minutes we will see the ice has completely melted in the container and the temperature would increases from 0 to suppose 20 degrees Celsius. something like this. Now we are going to heat this container again. When we heat the container, the temperature in the thermometer start rising. At 100 degrees Celsius, water starts boiling. We are able to see the water vapors coming out from the surface at 100 degrees Celsius when this thermometer shows the reading 100 degrees Celsius. Now continue heating the container for 5 minutes. After 5 minutes, again record the temperature. It is still 100 degrees Celsius. Means the temperature before 5 minutes is 100 degrees Celsius when the boiling has started, and after 5 minutes the temperature is still 100 degrees Celsius. So where does the heat energy go within these 5 minutes? That heat energy is called the latent heat. The energy which is not utilized for increasing the temperature but has been utilized for increasing the intermolecular spaces or for overcoming the force of attraction between the molecules of water. Now come to the topic, types of latent heat. The latent heat is of two types, latent heat of fusion and latent heat of vaporization. Now there is a slight difference between these two. The amount of heat energy required to convert 1 kilogram of solid into liquid state at atmospheric pressure at its melting point is called latent heat of fusion. Whereas latent heat of vaporization is the amount of heat energy required to convert unit mass of liquid into the gaseous state at its boiling point at atmospheric pressure is called latent heat of vaporization. So, after discussing these two types of latent heat, first of all, I would like to share with you the definition of latent heat. What is latent heat? The amount of heat energy absorbed or released during the change in the physical state of a substance without changing its temperature is called as latent heat. So students, you can write this definition in your notebook also. Latent heat, the amount of heat energy absorbed or released during the change in the physical state of a substance without changing its temperature is called latent heat. Clear? Now, I think that you have understood the concept of latent heat, that why the temperature is not rising since these 5 minutes. Now, I will try to explain this concept with the help of a graph. Let us draw a graph. This is temperature time graph. Firstly, the temperature increases with increase in the time. Then temperature becomes constant. Then again the temperature increases. Then again the temperature becomes constant. Then again the temperature increases. So this is the state of solid. This is the state of liquid. This is the state of gas. Now we have a solid. We increases the temperature, we heat the solid. Then at the melting point, the solid, when the solid starts getting converted into the liquid state, at that point the temperature remains constant till all the solid get converted into the liquid due to latent heat of vaporization. So at this point, at this juncture, where there is a parallel line to the x-axis, this parallel line represents the steadiness of the temperature, that the temperature remains constant, or this line shows the change of state. So we can say here fusion takes place or freezing also takes place. We can say melting or fusion means solid get converted into liquid, and liquid also get converted into solid at this point. So this is the fusion point or the melting point or the freezing point. Similarly, when all the solid get converted into the liquid state, the temperature keeps on increasing, and this is at this juncture we see that the line becomes again parallel to the horizontal x-axis, and this line represents so at this juncture we can see that the interconversion of the state between liquid into gas, and when all the liquid get converted into the gaseous state, again the temperature keeps on increasing. So simply we can see that at this point and at this point, these are the 2 points where the graph line becomes parallel with the x-axis. So these 2 points represents the conversion of states, means at this point both the states are present, solid and liquid both. Solid is getting converted into liquid, or we can say liquid is getting converted into the solid state. Similarly here the liquid is getting converted into the gaseous state, as well as the gas is converting into the liquid state. So when there is any change in the state, the temperature becomes constant due to this latent heat. Thank you very much.